two things. So this is our web page. So I guess you probably will be there. And then here, if you click the material, you can see the previous year material. And then if you click the presentation screen cast, it will show the YouTube channel for the institute. Here, this is the playlist for last year. And then we already start to uploading the previous sections. So Skyline and OpenMS section for last couple of days is already there. So you can see all of this. And then during the weekend or next week, all the courses for intro R and advanced R, all the lecture will be there. So please remember this one. And also the material, the Google Drive that we shared, we used before. Also, you can access all the other process material there. So you can check it after you leave if you cannot attend the next week. So that is things. And then people who leave tonight, if this is your last course, please pick up your certificate before you do. Okay. And then, it's the last session. So R Studio, I will open the R Studio. So mainly what I'm gonna do right now is previous section we calculate the mean or whatever for one specific protein. But we want to calculate for all the proteins. We're gonna do this. And then we are gonna repeat the plot for all the proteins. Then we also trying to look one of the basic testing, the t-test. We are trying to how to use the t-test function for one specific protein, and then how we can apply for this method for all the other proteins. And then if you have a time allowed, we get to the sample size calculations. So this is the what we did last section. So I will close everything. Then I will open the new R script. And then go to our folder. And then I will set here is the working directory. So at this moment, my environment is empty, so no data again. Then let's hold our IPRG data. So root under the data folder, please call the IPRG, and then now I have IPRG data. Then so I just reopen it. So I also need to call our package tidyverse again. I want to use the tidyverse packages library. Then previously what we do is from IPRG we subset for one specific protein and then use the summary function and then calculate blah, blah, blah. Then how we can calculate for everything. So I will start with the IPRG data. IPRG, from IPRG, I want to group by protein and condition. So previously we just group by condition, but here protein and conditions. So they're gonna group by combination of protein and conditions. So here, and then I want to summarize it first, mean of log2 intensity, and also another column called standard deviation, SE, for log2 intensity. And then I want to count how many observations we have, n. Right? So previously, we have only 4 rows for each condition. Then then I will make a summary all. I want to make a new table to include the summaries. And then I will check how the summary all look like. Here we go. So first 4 rows for the specific protein. For each condition, we have a mean, a standard deviation, and length. Okay? Then, also we can calculate the same thing, standard error and then confidence interval. So, I want to add another column, use mutate functions, summary all, mutate summary all. First, I want to make a new column called standard error. How we can calculate it is square standard deviation to 2 divided by length. And lower limit for the 95 percentile confidence interval should be mean minus QT .975, and then degree of freedom length minus L1 times standard error. And then for upper bound, it should be same. Now we have to change minus to plus. So here, upper, and then it should be plus. Then I run, and then you see here, well, there's a warning message, but I can check how the summary all look like. Here, they have a extra column now we can see. Then, why we have this error message? The error message seems that something they cannot produce, they cannot calculate this QT. What does that mean? So, I just want to check, it seems like they say the NA produced in that column, so I will want to double check what's the problem. So from the summary all, what we do, and then I just want to check. I want to filter out, I want to see some rows which include NA value in lower. And then here, this is the one of the case. It's only one case, which actually look like for this protein, for this condition, there's only one observation. So length minus 1 is 0, so they cannot calculate the distribution. So why they have it? Probably they have a missing value. We expect they have 3 values, but 2 values, there's no 2 value, only 1 value are there. So it shows some cases which they cannot calculate. Okay? So this summary all table, new table, have all summary value for all protein for all conditions. So now we are going to use this data, new data, and then we want to plot the same plot for each proteins. Okay. There are several, not several, but some way we can calculate it, we can draw it. But I will try the two method. So before I start to do this, I want to introduce a new function called for, and this. So this function for always need this bracket and then this another type of the bracket. So which means the for means we here inside of this parenthesis we can add any condition during the, if the condition is okay, then we are gonna perform whatever comment in the next parenthesis in the bracket. So I will show you what is that. I will show the simple case. So first, I just assign the one of the kind of the new value I. I want to introduce the I, and when I is 1 to 10, I want to print I values. So how it goes is, first they're gonna start 1. So I should be 1, and then they print I, and then they just go back to the first, and then repeat and repeat and repeat until I equal 10. So here, I said that I should be I plus 1. So, and I select all of this and run, so we show 1 to 10. Okay? So until from I equal 1 to 10, they're gonna perform whatever happened inside of this one. So I will use these functions. So I will introduce the R. When I equal to 1 to number of the proteins. So if I select this part for me, select this part, it shows there are 3027 protein. So I will repeat whatever it happened inside 3027 times. Okay? Then, yeah, it should be then. However, for just convenient way and then for time limit, I will just put this one is just. So we will draw the same plot from protein 1 to 10, and then we are drawing in the one PDF files. So first step is I want to get the summaries for first proteins. So from summary all, I want to filter protein name is equal to unique summary all protein OI. So let's assume I equal 1. I equal 1. Unique information of this protein is 3027. But among here, I want to get the first protein ID. So this one. I don't need to type this protein name itself. Just this function can find the first protein name. Okay. So if I equal to, I just change the I value, and then I will just run this one again. They're gonna select the second protein ID. So we don't need to type. Just automatically they can find what's the first protein ID, what is the second protein ID, and okay. Then let's go back to the I equal 1. And then here, this line filter, the protein ID is this, and then they subtract our summary and then call the sub. So if I run this line, how the subs look like is this sub have only 4 rows. This one have for the first the protein, and then they have a summary for condition 1, 2, 3, 4, and then other variable will be calculated. Then I will cheating to what I did in the previous section. So I will find my previous section script S05 basic step R file, and then I will copy this function. So when I make it and copy, and then I will paste here. And then I will change my input data file name. So let's check if I equal 1, how it look like. So I run this line, and run everything here, and then I set here print P to show the plot what we made it, right? Then if I run from here to here, they're gonna draw the plot here from 1 to 10. 10 different plots they're gonna plot here in this panel. However, I want to save this as some PDF file in one PDF file. So what I'm gonna do here, I will open the PDF files, and then file name is IPRG 10 protein error bar .pdf. Then I can decide what is the width of the file. Let's say 6, and height is 5. It would be inches, but we can change the dimension for that. And then after the for loop, I will close it. So if summarized, I will gonna open the PDF file and then draw the 10 plot, and then I will close it the PDF one. Okay? Then if I select all and then run, here still you can see this stop button means they are running, they are working. But I already can see here new PDF file under the my working directory. But if you click now, it will show the error message because they are still working and they're not finished yet. And then they're done. And let's open this. Here you can see there are 10 pages. It will show each plot for each pages. So if you repeat, here I just show from 1 to 10. But if you draw, you can draw for all thousands of proteins plot, and then you can make this file. However, here what I make mistake is, I don't know this one is from which profile, proteins, right? There's no naming there. So then I will change a little bit. So same plot, but I will change the title here. I will change the title here. Unique self proteins. The self is subset of for one protein. So I will change the title. Title, I want to use the protein ID in our subset data. Okay? Then I will rerun this. Take some time. Reopen it, and then here you can see now we can see the protein ID over here. So we can see this is a plot for the specific protein. Next one for the other protein. Next one is the other protein, and so you can just draw for same plot for every single protein and then save in the one file. Okay. Okay, then I will start to the similar things for t-test. So let's move to the t-test. First of all, I will start with the one specific protein. So we already have a IPRG. So same as before, I will subset for one specific proteins, IPRG, and then I want to filter protein is equal as P pi P44015 pi with C2 east 1. So then here you can see the one protein have 12 values, which include the 4 different conditions. T-test is only works for 2 conditions. If they have a 4 condition, definitely we have to use some different model, on-about model or something else. But here we are focused on t-test, which means we need only 2 conditions. So I will get a subset for condition 1 and condition 2, and then here just I can add filter when condition information condition 1 or condition 2. So if you have only one specific value, you want to look at it, you can use equal to 2 equal sign. However, if you want to subset for filter which include or a multiple value, you can use this side, include. So which means please filter if condition include condition 1 or condition 2. So then, when I run again, this will have only 6 values. So 3 value for condition 1 and 3 value for condition 2. So total 6 value, we only have 6 values. Okay? Then we will use this t-test function. So first, question mark and t-test show how we can use the t-test. So definitely start with the t-test and parentheses, and then we need to add the value, x value, and then here's the options. You can define what is an alternative hypothesis. You want a two-sided test or less than or greater than test. And if you have what is the mu value, or your design is a pair design, or you can assume the equal variance between the group or not, and then what level of the confidence interval you want to calculate it. There are several options there. And you can also check your default options. Then, here, and let's try t-test, and then parentheses. We want to compare log 2 intensity between condition from where I want to use the data 1 proteins. So from 1 protein data, we want to compare log 2 intensity between the conditions. Then I run this. Here, they show something, but it's also not a quite different format. Not the data frame, not the vector, some other classes. They just put out some other information over there. So they do the t-test, and then here's a t statistic, and then degree of freedom. This is a p-value, 0.012, which is not significant based on the FDR cutoff of 0.05. And then here's a confidence interval between these two. And then this is the sample estimation for group condition 1 and condition 2, right? So we can see this. And however, we want to save this output in the result. So if I run this, whenever later, if I call results will save all this result. Then, if I go back to this help file, first they show the argument, what kind of input we needed, we can change it. And then after detail, after they show what is the value. So how we can interpret the output. So for example, output of statistics show the t statistic, and then you can extract the p-value, and then we can also extract the standard error, and blah, blah, blah. So for example, here, if I want to extract the p-value only from the kind of documentation, result, dollar, and p-value show this p-values from the document. So here it shows the p-value here, but we can actually extract p-value itself only. And for example here, so if I want to extract the standard deviation here, STD, ERR, so result and dollar sign, STD, ERR, it shows the standard error value. So we can extract any value you want here. Okay? Then, okay, so here, what the common value we are interested in is p-value, and then the standard error. However, we also want to calculate the forward change itself. How much is difference? However, here, if you see here, they actually not showing the forward change itself, right? They just show the estimate value itself, but actually not calculate the what's difference. So what I'm gonna do, I will extract these two values and then calculate the minus, how much is difference. So first, result and estimate. Here, estimate mean or difference in means depending on where one sample or two sample test. So I run this. All right, they show these two values, and then I want to calculate this difference. So then here, I will use difference. It calculates what is difference from between these two. So second one minus this, and then they show what is the log 2 forward changes. Because here we are calculating everything is based on the log 2 scale. So this is a log 2 forward change. Then next step is, okay, we calculate this one for one specific cases. How we can calculate for all the other proteins? The first one is what we practice, we can use the group 1. So for 1 to the end of the proteins, we can calculate the repeat and repeat and repeat, like more than 3,000 times. However, we can also use the deployer, which actually makes some easier. However, need to understand a little bit of the syntax. But I will show the short version first, and then I will show the long version. So, for proteins, how we can calculate it. So first, we will start summary all, which already include so we have to start with the IPRG data because summary all is already calculated. So we will start IPRG. However, I will use first 5 proteins just for calculation wise. I will use the first 5 proteins. So before I will get the protein list, which is unique IPRG protein name. So now protein list actually have all the protein name. So we don't use unique blah blah blah. So now from now on you can use the protein list. Okay, so from IPRG data we want to filter which protein include first 5 proteins. And then we will call this is sub-IPRG. So now sub-IPRG data has information about the 5 protein information. Yes?
How is the 5 sign different from the sign?
So pipe means we are sending IPRG data to the next step. Include means this one is for subset. We want to get the subset when the protein ID include 5 this information. So this is for the subsetting. This is more likely next step, and next step.
it doesn't need to be for filtering. For any other next step, this is just sending to next step, but this is only for subset of data.
So row list is a subset of protein.
Yes, so if I run this protein list, means this is 5 protein list. Protein ID include this 5 protein, and then I will subtract that only that row, and then put it that data set into sub IPRG.
So it's just like if you don't use the percentage and percentage, you can directly filter. If you know the row numbers, column numbers, then you can directly say dollar of those numbers.
Yes, I think you mean. I think you mean. This?
Like instead of using that include sign, if I did just protein dollar row list, it will do the same thing
No.
as this does.
No. So if you, so this is, okay, this one is, okay, I will show the same things. If I make a long term, what it should be is protein equal, protein ID 1, or protein ID equal pro-list 2, or protein equal to pro-list 3, or, and then up to 5.
Got it.
So that is kind of shortcut.
Okay.
So don't want to repeat the same thing until 1 to 5. So, yeah, so now we have a subset IPRG. Then let's just start with the subset IPRG. For each in the sub IPRG, I want to filter condition should include only condition 1 or condition 2. So I want to subtract only first 2 conditions because t-test only for the 2 groups. Then, so okay, I will run only for here to here. So previously, subset IPRG have a 60 observation because 12 times 5. If I run this, here you should have only 30, which means 6 observation times 5. So among them, I want to nest by protein. Okay. I will put here is all result. Alright, and then I will check how all results look like. So we understand the first line. The from data set we filter out, and then I nest it by each proteins, and then there's the output. So we know we have 5 proteins. And then for each protein, here, for each this part, there's a nipple 6 by 6. Means this is another table which includes the 6th row. So even though it like the, this, so, and each one is a cell, this is a value in a cell. But in this cell, actually they have another small table inside of the cell. This is what we call the nest. So we actually group by each protein, and then for each small table, we are gonna calculate it. So, and after that, we want to make new table, mute, and then fit means we will fit the model. And then how we fit the model? We will use t-test, and then log2 intensity. We want to compare log2 intensity between the conditions. And then data should be dot. It's picky. This is getting complicated. So this is just syntax 1. And then here we have to put the map. The map means we are going to perform whatever, any function inside of this map function, repeat by each protein. Then for each fit, I will subtract the value, t step value, and then that is from fit and statistic, and then standard error, also from map, fit, SDERR, and then P value is map, ER, and then fit, P value. Anything you have?
Yeah. So I just missed how you fixed it.
Yes. I changed that order. I changed this part. You still got an error? basically idea is we can get it up to here, and then for each protein, if you go back to the line 61, there is a basic t-test for one protein. I will copy that one in this row. However, here, previously, now we have this data column after nested. In each cell, we have a small table we can compare. So here we call, now we are gonna use not sub IPRG, we are gonna use sub data set and then compare it. And then that map is kind of another function. They can just make a link for like small pieces of information. Yes.
Sorry, could you explain some of the flags in here?
Flags?
Like what the tilde actually means as,
This one?
yeah, like that.
This is actually really defined by the map.
Okay.
So they pretty much, any kind of function you want to use previously, just put the tilt on it, and then they recognize this is the start of the function what they are going to apply
Okay.
in the unit. Okay? Then, if I double check again for our output, old result, here we have a 5 data set, 1, 2, 3, 4, 5 different protein ID. We have a t statistic value, and then we have a p-value over here. So if you assign this one for all the protein, you will get the 3,027 rows for every protein. Okay? So this is how we use the deployer one. Let's try to do the root one. It will be more simple, like not hidden, more straightforward, but it will be a little bit longer. Okay? And before I start, I will copy whatever our t-test function here. And then here I said I will use the root function. For root function, I will always start the for function, and then I will define I should be 1 to the length of our protein list. The protein list vector, we already get all the protein ID. So length of the protein list shows how many the proteins we have. So I should be repeat 1 to 3,027. However, just also this case, I will replace this is 5. Okay, so from I 1 to 5, I will repeat whatever inside of this. Okay. Then first, let's assume I of equal 1. I want to subtract the protein ID, the first protein ID. This is the same as before. I want to say call sub. It should be from IPRG. But I want to filter protein, and this time equal because we want to extract only one. But you still can use this function. For one value, it is the same. It will be the same. So here I said the protein I list I protein name. Then if I see sub have a 12 observation, okay, then I need to filter for condition again. The condition also should be condition 1 or condition 2. Then now this one we have 6 values. Then I will compare this next step. T but now this input should be self. If we use one protein, we already defined the one protein out of the fold. So it will be fixed value. You see, if you repeat, they're gonna keep you the same thing again, right? Inside of the for, we every single time when we're looping, we want to change our input. Then what we need to test in also should be the new ID when we change the subset. So here, subset, always each time subsetting some different protein ID. So and then I need to use that specific subset of the data set. So here it is the same. Then, okay, we can test it. However, the most important thing is, okay, data's testing 3,000 times, then what? We need the output. We need to subtract the output, and then we want to summarize everything and then make a new data set. So we need to go out of the loop. Means first, before we start looping, we need to first make some data structure first, empty data set, and then whenever we calculate it, we need to put the information and then fill in the tables. So first, I will define the all result table as a data frame. First, I will make a protein name as NA. Just now, I make everything is just empty. And then I will make a T stat column. That one also will be empty. And then next is p-value column. I will make this is also empty. I just make a just framework, and then whenever I just calculate it, I will add a new value in this framework. So here I run this, and then all data. Here this will look like. So I already defined the 3 column, but so far I don't have any value here. Okay. Then in the loop, whenever we calculate it, we are gonna plug in what we are calculate value in our all result set. So all result are find or result So first one should be protein name in the subset, the sub data set. So here I will put first name was protein. Okay, so before I make this one, I will say temporary one. Data frame, protein. Now this one should be the unique cell protein. And then next, T stat value is from result, what we calculated. And then statistic. And then P value is from result. And this p-value. So when we run this one, so what the temp look like? Temp include the result, p-value, and t-tested from our t-test. So we make one of the simple data frame. And then we will combine this temp data set under the all result. So you can see now all result, they don't have any value, but temp data set we have, we will combine this to the all result. Then now here all result now have look like this. So previously everything is NA, but now we have the value here. Okay. Then let's assume, okay, we are done for I1. Let's go back to the I2. What's gonna happen? I will run everything again. And then how it look like, or result. Now they add the second result under the all result, right? And then if you repeat and repeat and repeat it again, they're gonna keep adding the new result for the new proteins. So then if I remove this and then just assume everything is okay, and then I run this everything here, all result should have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, the result. It should be there. And if you want to run everything for all the proteins, you can just replace this one, length of IPRG, and then run from here. Okay, then I will just want to print I. Just track where we are. Whenever they are, each looping, they're gonna show what is the I value, which means we can actually track where we are. And then if you run here again, we have only 7 values. No, this is I pro list. And then we can see how many proteins are calculated. Okay, then the stuff probably they have some issue for that specific proteins. But here I can see up to that proteins we have full testing result for the proteins. Okay, so we actually calculate the same thing. One is to use the dplyr and then one is the looping, but the loop function is more difficult. We need to set up the data frame first, and then we need to individually, manually extract the value and then put everything again. If you use the dplyr, it's quite simple, even though the code itself looks not that much easy to understand. But if you run this one, we also can calculate that. So you don't need to individually copy each for each protein. Okay? Yes?
Why do we need to create or initialize an empty data frame first? Is it for memory that we do that?
So, for example, here actually, that is also a good question. So, there's two way. If you know how many, how big data table we want, we actually can define that one. And then that is actually for memory-wise is quite safe because we already define and then just put it into just find the location and then put it there. But
Creating it.
yeah, but here what I did is here I didn't specify the dimension for this data, right? Which means every time I need to create it and create it and create it and add and add and add it. So memory-wise, actually this is more, yes. But dplyr itself, we don't need to worry about it. They just take care of everything. But if it is a little bit like the looping, the more complicated calculation-wise, dplyr will be a little bit slow. Then more, the long, the command line. Okay. So then let's go the final one. So sample size calculation. We are gonna do some typing again, but it will be much shorter. So if you go to our manual, here's the sample size calculation part. And to calculate the sample size, this is the formula, like what we calculate the standard or confidence interval. This is the formula. And then here, n is the sample size per conditions. To calculate this, we need other numbers, right? We need to predefine this value, and this value, and this value, right? So here's the for value. To calculate the sample size, we need to define the what level of the confidence interval we want, how much power we want, what is our anticipated for changes, and then what is the anticipated variance. If you don't know the variance, somehow you need to get some variance information from your pilot study or and so on. So this is a more important factor, how much variance you want and you can expect it. So for that, we actually can use another package for power. So to use that, we need to call this package first. So how the simple case we can use this function is, there are several power calculation. The power calculation and sample size calculation always comes together because, as you can see here, we can calculate the power if you have other variables, other values. So we can use the same function to calculate it. So for t-test case, we can use power t-test. However, when I start to type it here, you can calculate the power for quite different type of the testing. So what kind of testing you have to use is really depending on your experiment and then your data and then your goal. So for example, if you have a categorical variable and categorical variable, definitely you cannot use the t-test. You have to use the chi-square and something else. If you have a quantitative value and then categorical variable, let's go back to the okay. So we always talk about the t-test or ANOVA, but this is really depending on your case. So for example, first quantitative response with the quantitative predictor. So numbers and numbers. Number equals number, we can use regression models. Second one, categorical response and then quantitative predictor. So for example, we have a number of numbers and then the output is categorical. For example, disease or healthy. Then we can use logistic regression or multinomial regression, something else. We cannot use, in the case, we cannot use the regression, just regression. Third one, if we have a quantitative response from categorical predictor, for example, from disease group and healthy group, they have a different amount of the protein level. So in that case, we can use ANOVA models. And then if we have a categorical response versus categorical versus variable, and then we have a number of the count for each combination, in the cases we have to use the chi-square or some other method. So this is really depending on your data set and then your goal, you have to use a different testing methods. So that's why we also can calculate the power based on different testings. So in that case, we use the t-test. So I want to calculate the power for t-test. Here we go. And then we need to define the four values. The first one, C level, we want what level of alpha you want. So first, I define the alpha is 0.95, and then I want to define the power, what I want, let's say 80%. And then I can
Say alpha is 0.95 or 0.05.
alpha is 0.95.
It corresponds to 0.05.
Yeah. And then we define the anticipant, the forward change and variance. However, in this function, they call D. D is just delta minus sigma, which means forward change divided by the variance. And then we want to calculate this one for 2 sample test.
What is the D again?
So I will show you the t-test. Here. So for use this function, we can define significant level and then power and then what type and so on. But here D, they call D, effective size is anticipated forward changes divided by the variance. So here I just define this, and then here significant level should be 1 minus. Yes, it should be 1 minus.
Sorry.
Yes,
So if you say anticipated fold change is 1,
yes.
you mean like 100% or?
So no, 1 forward change, not 100%. Just difference between the mean value estimation.
The absolute one or the relative one?
It's depending on your data set. So for example, here we use the log intensity case. That means log 2 forward changes. So here I run this. It shows the result. So here I need sample size 5 point something when D equal 2, and then this is a significant level, and then power for 2 sides. So in this I need 6 sample per condition. This N value is for conditions. How many sample we need? Yes?
Just repeat what 0.5 is the D equals fold change divided by 1.
Yes. Yes. Forward change divided by variance.
Wait,
Sigma. Yes.
But I get only D the size. If my fold change increases, my noise can also increase. That's fine.
Yes. So then I will show you some changes. So from this point, you actually don't need to type it. I will just change because we already defined this D value. I will change the 4 changes, and then I will take the variance and then looping, and then each combination how it look like, how many sample size I needed. I will try to draw it. However, you don't need to actually type it. So I'm gonna use the some looping one. But here, first I will define the sigma from sequence 0.1 to 5, 0.1. That means I want to test sigma from 0.1 to 0.5. But so if I see the sigma, then I want to test this 5 different sigma values. And then same as this, for change, I will also want to test from 0.1 to 0.7, and then also increment is 0.1, and then which means I will test the forward change from 0.1 to 0.7. Then, in this case, I will define the matrix for result.
So I will put all 0 in each cells, and then I want to end row is 7. No, 7 times 3 is 21, and then I want to column the 3. So if I run this, how it look like? I just make a matrix, and then after I calculate it, I will put all the numbers in there. So what I'm gonna do, first, I will start to I, that is for different 4 changes. So 1, 2, 7, and then for each 4 change, I will test another grouping that is for 1, 2, 3, that is for different sigma. And then for each cases, I will test, I will calculate the sample size. It should be same sigma net level, well, minus 0.95, and then power equal, let's say, so 95%. And then here D can calculate by the 4 changes in sigma. So here I will use the sigma for first sigma. It should be J, and then 4 change should be I. So what does that mean is when I select the I1 first, and then I select the J first, J1 first, and then get the first element of the 4 change and first element of the sigma, and then calculate everything. And then when I come back, I will repeat inside first. Still I equal first, but when J equal 2, how it look like, and then calculate it. And when I equal 1, and when J equals 3, how it look like. Whenever I finish this sigma, and then I will go out and then get the second 4 change, and then repeat for the other 3 sigma, and then repeat and repeat it again. So 3 times 7, so total we have 21 cases, we can repeat it. And here I just counter, this is for how we can define which row we have to put it. So counter should be counter plus 1, and then I will put our result in our define the matrix. Here counters row, first one I will put our delta, the D, which is calculate FCI minus divided by sigma J.
If you not just put 1, 0,
Mhm.
or, sorry, 1 is P since you defined delta above. So sample size.
So yeah, here I already, yes, we can define the outside, and then we can use this.
Oh, it has to be outside.
Yeah, outside of the functions, outside of the function. So yeah, here, yes. We can define this D first, yes, and then we can call this D is D. And then here we can use the here D. Right. And then here I will copy this and then repeat again. And then I will put here. That is for, no, we already have a that value, so I will set here, I will just put the sigma J, because we already used the same, just one significant value, one significant power, one power, so we don't need to know this, but I want to know sigma value and the 4 change values.
need to put the actual result here. And then I will put this as a ceiling. Means I want to round up. So I already run this one. So here I run here. And then it will show this. But here there's no labeling, so I'm confused. So I will define the name in this matrix. The first one should be n, sample size, and next one is sigma. And then next one is for change. And then here it showed all the result. So let's see here, when for change, anticipate the for change is 4.7, if you have an increase sigma, if you have a more variance, we need more sample size. So here, when for change is 0.06, if you have a more sigma, we need more sample size, right? And then let's focus on if we have a same sigma, let's say here, here, here. If you want to detect small for changes with the same power, we need more sample size. Make sense? So if you compare here, for example, here for changes is 0.1, is very small, tiny for changes. With the same power level, we need this much sample size. And so on. Okay? So this is just to show them how many sample size we need for different cases. But for your case, if you want to calculate the power for your next experiment, we need to know the anticipate the for change and variance. You can get this information review or other published data set because it can be very diverse across the organism or the next. Okay? This code is in the materials. If it's too much typo and then you can get it, you can just copy and then you can just run it. Okay, so this is, I think I covered pretty much all the topics. Yeah. So if you have questions, please let me know. I will be here like around 6 p.m. today. And okay, so this is the last one, so I need to wrap up everything. Okay. So we are finally done for intro R. Hopefully it can help you for learning R. And then I hope it can give you the good impression for R. Don't afraid to use the R. We have a lot of the typing and then typo. This is really common. And so one example is I run like some thousands of line code, and then it keeps an error, and then I keep looking at like where's the error for 2 days, and then finally I found I missed the 1 comma. So for 1 comma I spent 2 days to where's the issue. So this is a quite common one. So that's why our studio also kind of keep developing to give it a more GUI. So if we have some error, they try to show some error, bad message or something. I hope it can be helpful. One, even though it's really a lot of the typo and so on, I still recommend to write the script because first time it's hard. It's not easy and we can make many mistakes. However, if everything is wrong, okay, next time you don't need to repeat again. Next time you don't need to repeat again. You can just change the file name and then you can automatically get it. it will be make much easier your life. Just spend some hours for first script, and then it will be much easier. So that's why I just want to recommend that art. And as I showed, there are so many materials around there. Google, just Google it. I still Google quite a lot. If you have an error message, I just copy and then Google it. There are so many answers. Even sometimes it's not working for me, but it's just trying error and trying error. So thank you for coming. I hope I not too much exhaustive for this week, and hope all of the participants next week will come again. Don't give up, and have a great weekend. Thank you for coming. Yeah, and then have a nice weekend, and then see you next week, and then see you around where.